question number 1. Okay, so question number 1 through 10 is the 3-point samples. So let's just go. So number 1. Which of the shown squares is split into 2 parts that do not have the same shape? So what we're underlining is not, and they cannot have the same shape. So once it's split in half. So that's what we're going to keep in mind over here. So it has to be the same shape that we're observing. So we're going to use the cross out multiple choice stuff. So we're going to split everything in half for now. Split everything in half. Okay. Now once everything is split in half, we're going to see which ones have about the same shape. So let's look at A. So A does have the same shape because there are rectangles on both sides that look the same. So A is good. Now B, it has triangle there, so it is able to work, and there's also lines on both sides, so it works. C, it looks symmetrical because there's point there, rectangle there. There's also a rectangle. Yep. And then you include that C works. Now D, there's a point there, and it's basically just mirrored. So yes, it works and it's symmetrical. Now for E, it does not work because it's the only answer left. Ooh. And also because there's a rectangle there, and there's just a tiny rectangle there, but there's an L shape on the left side. So this one does not work. So our answer that we will circle is E. Alright, so on to question number 2. These are one of the easiest ones because it's only multiplying and dividing. Let's pull out the written color. Okay, so number 2. What we're solving for is 2 times 0.24 divided by 20 times 2.4. So what we can do is we can basically see if there's any common factors, and we can cross it out. For example, 2 and 20, where they're both divisible by 2. So 2 on the top becomes 1, and 20 on the bottom becomes 10. So now we can see if the other ones have similar factors. So put on the equal sign, since it doesn't really. We can just do 0.24 because it's 1 times 0.24, and 10 times 2.4, and since that we just moved the decimal point, so it would be 0.24 divided by 24. And now to do this, you can do the division way. So what we will do is we can multiply by 100 on each side of the dividing thing to get rid of the decimal point. So now it'll become 24 divided by 2,400. Alright, so now we can see if they have similar factors. So since 2024. Okay, anyways. Since that doesn't go, we go 0, and then we put in decimal point. And then another 0, because it doesn't go in. So now it does. So now we do 1, so 2,400 minus 2,400. And that is 0. So what we get is 0.01 as our answer. So now knowing that, we are able to circle A as our answer. Alright, so on to question number 3. Okay. The number of points on opposite faces of a die is always 7. We define the vertex sum in a vertex as the sum of the points on the faces that meet in the vertex. Example, the faces of the die with 1, 2, and 3 points meet in P. Therefore, the vertex sum in point P is defined as 1 plus 2 plus 3 equals 6. Which of the following numbers is the biggest vertex sum in the vertices Q, R, and S? Okay, so we're going to grab different colors. Okay, So let's do into the dice. Okay. So for red, we're gonna outline the vertices of Q, which is there, and then I'm gonna grab a different color to outline the vertices of R. I'm gonna use green. So the vertices are there, there, and there. Now different color for S, we're gonna use blue. So then the remaining vertices are for S. Alright, and now we need to find the vertex sum. So what we're gonna do is we're gonna use a different color now. Ooh, okay. So we're gonna keep in mind that there are opposite faces on the side of the cube. So we're gonna write them down so that we know. So here's opposite faces. So what's like on the opposite side? So, oh, that line was not straight. Okay. So 1 has the opposite to 6. 6 is on the bottom of the cube. 2 is on the opposite of 5. So 5 is on the behind of the cube. And then what's next? You have 3. So then that leaves us 4 to be on the opposite side of 3. That's what we're going to keep in mind. So now, let me just erase the previous problem so we don't get confused. Okay, anyways, let's continue with number 3. Okay, so then now that we know all that stuff, we can add up the vertices. So let's start with Q. So Q, our vertices that we have is 5, 1, 3. So then what we can do is we can add it. So 1 plus 3 plus 5, since it says to find the sum. So it's 1 plus 3 is 4, and then 4 plus 5 is 9. Or you do 1 plus 8, which is 9. Okay. So then, next one, which you did green, you're going to find R. Then you look at the cube again to find its faces. So R, oopsies. R has the vertices of, 2, 3, and then 6. So we're adding those together. So 2 plus 3 plus 6. And that equals 2 plus 9. That equals 11. So that means you have one more left. So we use the color for S, which we will look on the cube again. So S contains the vertices of 1, 2, and 4. So you add 1 plus 2 plus 4. 2 plus 4. Okay. Then now we just add it up together because we're trying to find the biggest vertex sum, as said before. So then 1 plus 6, and that is 7. So now biggest vertex sum, as we can see, is 11 from what we calculated. So we can answer that. And then now we see that we can circle letter D. So question number 4 says, a type of hopscotch is played in the following way. Each player plays from one square to the next with his left foot, both feet, right foot, both feet, etc. Alternatively on the floor shown. Maya plays this game and jumps into exactly 48 squares starting with the left foot. How often is her left foot on the floor in this game? Alright, so what we do is, let me change the color so you can label which is left and right. So here, the top is left, the bottom is right for us. So it says she plays this game and jumps exactly 48 squares starting with left foot. We're trying to find how often her left foot is on the floor. So we can circle which one's the left foot, so that's 1. So that's 2. The third box has no left foot, so we don't count that. The fourth box has a left foot. And then that line is where the pattern ends. So now, after just that, the pattern just restarts over again and keeps going. And it says exactly 48 squares. So we're going to underline that. And for the work for number 4 is we can basically find how many squares she is going to jump through for the pattern. So what we do is 48 divided by 4. One, two, three, 4. So that's 4. Yep. Then that's 12. So her pattern in total repeats 12 times that she plays. So to find how our left foot is there, we do left foot. Okay. So then we do 12 times of times that her left foot is on there. So 12 times 3. And that equals 36. So our answer is 36. Her left foot is on the game 36 times, which is C. So on to number 5. Let's go. Alright. Tim wants to draw the figure shown without lifting his pencil off the paper. He has to pass over some parts more than once. The segment lengths are stated in the figure. What is the minimum length of the total line he will draw if he chooses to start his point freely? So the thing that we underline is minimum. So what's the lowest number that he can't go through while drawing this in one line? Let me use a different color. So there's a super efficient way, so I'll show you guys that instead of a lot of every single method. So it says freely, since you start freely, we're going to start over there by the 3 centimeter point. So we're starting there. Then using another color, so then it's more efficient. So you can go down the 3 centimeters first. That's 3. While we're doing this, we're going to set up our equation. So it's 3 plus, and then, oh my god, okay. 3 plus, let's use a different color. Let's do that. And then we go 1 centimeter, and then back to that 1 centimeter, plus another 1. So it's plus 1 plus 1. Add it to our equation. Another color. We go down 2, and then we go up 2 again. So now we do that to the equation, plus 2 plus 2. Then different color, we use plus 1 because they're going down 1 and up 1. So we add that to our equation again. Yet another color. Now we have another 1 left, so we go there and then back. So then plus another 1, plus another 1. And then we do a different color. We just go up to 2, and then that's done with the thing. So then we just add plus 2 since we ended there. Put it to our equation. Now we can solve it. So now we add it all together. Let's see. 4 plus 3 plus another 3 plus 3 plus 3, and then plus 2. There we go. And plus 3. Okay, there you go. So then it's 7 plus 3 plus 5 plus 3. It's 12 plus 3. And now the answer is 15 centimeters. So the lowest number that we can get is 15, which is B. Question number 6. So the figure shows a square with 4 circles of equal area, each touching 2 sides of the square and 2 other circles. What is the ratio between the areas of the black region and the gray region? So let's look first. So let's find the area of the box first. So there are 4 circles. So we can assume that these 4 circles will fill the area. So it's 4 times 4, since that's how I find the area of a square. So 4 times 4 is 16. So knowing that, now we are able to get the black area or calculate for it. So since there are 4 circles and assuming that black area is box, it would be 1/4 of the whole square. So you do 1/4 multiplied by its area, which is 16. So by doing that, we can put it to be 16 over 1, so it can be easier. And then we can find if there are any common factors, which is technically 4. So we can cross out, and then it becomes 4. So that's the black area. Now what we can do is we can calculate the gray area. So since 1/4, what you get left of the square, that would be 3/4, because 4 over 4 minus 1/4, which we already calculated for, equals 3/4. So that's how we get 3/4. So 3/4 multiplied by the area, again, which is 16. We can make it 16 over 1, so it's easier. And we can see that there's another big factor of 4. So then 3 times 4 is then 12. And it's asking for the ratio between the areas of the black region to the gray region. So the black region, we'll write ratio. Okay, so the black region, it's 4. So we'll write that to 12 from the gray region. And since there's basically a common factor, we can both divide 4 on both sides, and it'll be 1/3. So our answer is B. Alright, so question number 7. John makes a sequence of structures on a table beginning with 1 cube. He makes the next structure by adding 5 cubes which hide the visible faces of the initial cube as shown. What is the smallest number of cubes he needs to add to the second structure so that all the visible faces of the second structure are hidden? So keyword is smallest because that's what we're gonna find. So, alright, so initial cube is the gray cube, which is the smallest one. And the second structure is the one with 5 cubes, basically stacked on top of each other. There you go. Okay. So then now it says another thing that we're gonna highlight is visible faces and second structure are hidden. So yeah. Okay. So what we can do first is add 1 cube on the top, which is there. And then we are going to add 2 times 2 since we are covering 4 from the bottom. And then we're going to cover 8 cubes on the level of the table. And to do that, each cube has to have 2 rotations of the initial cube. So 4 times 2, that's how we get there. So now we do 1 plus 4 plus 8. So then it becomes 5 plus 8, which equals 13. So our answer is 13, which is D. Alright, number 8. A 3-digit palindrome is a number of the form ABA where the digits A and B can either be the same or different. So what is the sum of the digits of the largest 3-digit palindrome that is also a multiple of 6? Stuff that we're going to underline is A and B, same or different, 3-digit, and multiple of 6. So we need to focus on that the most. Alright, so we can write multiples of 6, and that includes 6, 12, 18, 24, and 30. Alright, so now knowing that, we can cross out the answers on the side that are not multiples of 6. So 16 is not a multiple of 6. 21 is not a multiple of 6. 20 is not a multiple of 6. So the only thing that we have left is 18 and 24, which should be one of the answers. So now we can cross that out on our multiples list on the side. Alright, so then now we can get the even and the largest 1-digit number. And the largest even and 1-digit number is 8. So 8 could equal 8. So since ABA, can do a equals 8, so 8 plus 8. We could, for b, also even and largest. So it can also be 8. So it's ABA, so A plus B. So we're switching on the order. So 8 plus 8 plus 8, and that equals 24. So our answer is 24, which is E. Alright, number 9. So Martin draws a square with vertices A, B, C, and D with a rectangular hexagon with side OC, where O is the center of the square. What is the measure of angle A? So we're trying to find angle A. So for D on the corner, we know that it's 90 degrees because it's a right angle. So now we can find O because we know that a hexagon has each angle is 120 degrees. That's how we know that. So C, it's also a 90-degree angle, except it was cut in half by the hexagon. So now it's 90 divided by 2. So that's why it equals 45 degrees. So now everything there adds up to 360. Since we know that, that's the sum. That's 360 again. Okay. So then, now what we can do, we can find A by doing 360 minus 90 plus 120 plus 45. So that, when we simplify it, 360 minus, let's do this, okay. So then that equals 210 plus 45, and that equals 360 minus 255. And then this means our answer is 105 degrees for angle A. Okay. So 10. Let's go. Our thing encloses a rectangular field with 40 meters of fence. The side lengths of the field are all prime numbers. What is the maximum possible area of the field? So that's what I underlined. So now from the information that was given, we know that the perimeter of the rectangular field is 40 meters. And now, basic information, the perimeter of a rectangle is 2 multiplied by length plus width. So now, since we know the perimeter of the rectangle, we can plug it into the equation. So 40 equals 2 multiplied by length plus width. And that can simplify to 2 length plus 2 width, and then we can divide by 2 to get the variables by itself. So 20 equals length plus width. Okay. And then to make it easier on ourselves, we can put the variables on the left side and then put the number on the right side. So now this becomes length plus width equals 20. They're both the same, by the way. So now since we want all prime numbers, what we can do is we can figure it out from the multiple choice. So 9 and 11, that does not work, so we can cross out A. A is not one of our answer choices. D, which is 84 meters squared, is 2 and 42. 42 is not a prime number, so 84 will not work. So 96, 2, wait, we can actually do 3. 3 and 32 does not work, because 32 is not a prime number. 51, we can do 3 and 17, which does work, so we can keep that for now. And 91, which is 7 and 13. Now it's asking for maximum, which is the biggest, so that means E is not our answer, and our answer is rather C. So now we can see that 7 plus 13 is 20, just to make sure. Yeah, our confirmed answer is C. Number 11. So for questions number 11 through 20, now it will be 4 points each. So let's just go. Okay. So a rectangle is divided into 3 regions of equal area. One of the regions is an equilateral triangle with a side length of 4 centimeters, and the other 2 are trapezoids as shown in the figure. What is the length of the shorter of the parallel sides of the trapezoids? Alright, because the triangle is equilateral, its altitude is 2/3. We know that because of theorem. So now, what we can do is we can find the the area of the triangle. That is 1/2 base times height. So it's 1/2 times 4 times what we just found is 2/3. So now since 2 and 4 have a common factor of 2, we can cross that out. And now 2 times 2 square root 3, and that is 4 square root 3 as a result. So that is the area of the triangle so far. Alright. And now to find the area of the whole rectangle, we can do 3 multiplied by 4 over 3. And that is 12 square root 3. Alright. So then now we can do, so we can find its length. So that is 12 square root 3 divided by 4. And then that is 3 square root 3. So now to find the length of the shorter parallel side of the trapezoid, what we can do is do another length and short, length, short, so then we know the difference. So then we can do 3 square root 3 minus 2 square root 3, which is what we got earlier to find the length. So then now what we get as a result is square root 3. So our answer is B. Alright, let's go number 12. So Martha places the capital letters A, B, C, and D into the 2 times 4 table shown. Exactly 1 letter is placed in each cell. She wishes to make sure that each row and in each 2x2 square, each of the 4 letters appear exactly once. So in how many ways can she do this? So the letters A, B, C, and D can be arranged freely in the 4 squares in the first row. So for example, there could be 4 options in the first square. So it could be, first square could be 4, 3, and 2, and 1. So now what we can do is do this, which means basically 4 times 3 times 2 times 1. So then this is 12 times 2, which equals to 24. Alright, that one is 24. Now for the second row, you have to consider the second square of the second row since it's 2 by 2 square. So this can't be the letter in the first or third position of the first row, so it must be the same letter as in the fourth position. So therefore the second row is the same as 24 options. So basically our answer is B, which is 24. Alright, number 13. Senja cuts out 3 circles from 3 different pieces of colored cardboard. He places them on top of each other as shown in figure 1. He then moves the circles so that all 3 circles are tangent to each other as shown in figure 2. In figure 1, the area of the visible black region is 7 times the area of the white circle. What is the ratio between the areas of the visible black regions in the 2 features? So what we can underline is visible black region is 7 times the area of the white circle, because that is important. So we have to find the ratio. Alright. So now figure 1, let's put that on the side. Alright. Figure 1. Okay. So we can abbreviate that into F1. Alright. Also, our variables, I forgot to mention before. White is W, black is B, and then G is gray. So that would make it easier for us to do. White, black, and gray. Okay, that's how the variables work. So F1 is equal to B minus G. So then that would equal to 7W because it is 7 times the area of the white circle. So then, since we use that, we now use the equation for F2, which is then just 7W minus W. So that equals 6W. So now, what we can do is the area ratio is 7W to 6W, and we can just cross out both the W's because, yeah. So now our ratio is 7 to 6, so it's D. Alright, 14. Mary's daughter gave birth to a baby girl today. In 2 years' time, the product of the ages of Mary, her daughter, and her granddaughter will be 2024. So Mary and her daughter's ages are both even numbers. What is Mary's age now? So what we can underline is 2 years' time in even numbers. 2 years' time. So keep that in mind. So baby girl, we can abbreviate to BG. So that is 0 plus 2. So now in 2 years ahead of time, we should be 2 years old. Now Mary, which stands for M as a variable, since it's 2 years ahead, we'll do 2M. Daughter, for Mary's daughter, we'll do 2D. So now their products of all that is 2024. So what we can do is 2024 equals 2 multiplied by 2M multiplied by 2D. So then what we can do is we can divide 2 on both sides because that's the easiest. So now what will be left is 1112, which is then equal to 2M and 2D. And now 2 times 2, so what we can do, divide by 4. So now we can basically get 253, which is M equal to N multiplied by D. So now we can prime factorize it, which is 11 and 23. And we can plug it back into the top of the equation. So since Mary is the oldest, we are doing 2 multiplied by the largest prime factor, which is 2 times 23, which is 46. And then that means her daughter is 2 multiplied by 11, so I said 46, and then 23. So now since it's 2 years ahead of time, and it's asking for Mary's age now, which is today. So now what we do is 42 minus 2, which is 44. So Mary's age is B. Number 15. Okay. A point P is chosen inside an equilateral triangle. From P, we draw 3 segments parallel to the sides as shown. The lengths of the segments are 2M, 3M, and 6M. What is the perimeter of the triangle? Alright, so let's use blue. So we can basically make shapes inside a triangle itself. So you can see this tiny triangle on that, and that'll be one tiny equilateral triangle. So it's 3. Oh, wow, okay. So now we can make another one around the 2 and 6. So it's another equilateral triangle, it's bigger. So now it's all 6. Okay. Now we can label, that's 3. And now this is 6. Okay. And now we can drag it on the bottom, which is 2. And then we drag that on the bottom, which is 3. That's how we get there. So now we can find the total of the length from B to C. So we can do 2M plus 6M plus 3M. So that equals 11M. Now to find the equilateral triangle, the whole perimeter of it, we can do 11 multiplied by its 3, because there's 3 sides of a triangle. So 11 times 3 is 33 meters, so the perimeter is 33 meters, which is C. 16. A number is written in each of the 12 circles shown. The number inside each square indicates the product of the numbers at its 4 vertices. What is the product of the numbers in the 8 gray circles? Alright, so to make it easier, I'll draw a separate box on the side so it doesn't have to overlap the other ones, because we're going to put variables in it. So A, B, C, D, and then E's on the inside. That will work. Okay. And now we can put factors into each of these. So we can do another equation to find the product, which is for the numbers in the 8th grade circles only. So what we do, we'll plug in those numbers. 10 times 4 times 24 times 6 divided by 12 to the power of 2, or 12 squared. Alright, and basically how we get this is we do A, B, C, D divided by E squared. That's how we got it. So now, on the diagram, the original diagram they gave us, we can put variables in there to make everything make sense. 1 is going to go outside of 4, 5 is going outside of 10, 2 is going outside of 6, 24 is 1 on the outside. Now the rest on the inside is 2, 1, and 3. That's how our variables will go, so then everything can fit together on the squares. So now, for our equation that we got, the equation would equal to 40. So then there's another way that you can do it after you found like things that we did before in the original. So you can do 5 times 1 times 1 times 1 times 4 times 1 times 1 times 2, because we're only looking for the gray ones. So then now 20 times 2, and that equals 40. And basically we got the same answer. So now our answer is B, 17. There are 4 vases on the table. Sweets have been placed in the vases. The number of sweets in the first vase is the number of vases that contain exactly 1 sweet. The number of sweets in the second vase is equal to the number of vases that contain exactly 2 sweets. The number of sweets in the third vase is equal to the number of vases that contain exactly 3 sweets. The number of sweets in the fourth vase is equal to the number of vases that contain exactly 0 sweets. So how many sweets are in the vases together? There are 4 vases. So that means that it would be adding. So I'll draw vases to make things easier. So these are vases, by the way. They don't look like it, but I tried. This was in a rush, but okay. Number of sweets in the first vase, second, third, fourth. Okay. Number of sweets in the first vase contain exactly 1 sweet, so we don't know anything about that. Let's see, number 2. The number of sweets in the second vase is equal to the number of vases that contain exactly 2 sweets. So first off, we have to know that none of the vases can have more than 4 sweets, because that would imply there are more than 4 vases, so that means the number of sweets in each vase would range from 0 to 3. So then, now, since we know that, we can read it again. So let's say number 1 has around 2 sweets, and the number of sweets in the second vase is equal to the number of vases that contain exactly 2 sweets. So we can say there's 1. So the third one basically says 0. And then the number of vases that have exactly 0 sweets, so that's 1 vase. So now 2 plus 1 plus 0 plus 1, that's 3 plus 1, and that equals 4. So our answer is C. Okay, number 18. A rule has n to the power of 3, where n is greater than 2 identical small cubes. He used these to make a large cube and painted the entire outer surface of the large cube. The number of small cubes with only 1 face painted is equal to the number of those with no face painted. What is the value of n? So there are n minus 2 to the power of 2 small cubes with a small painted face visible on each face of the larger cube. So the total number, since there's 6 faces on the cube, would be 6n minus 2 to the power of 2, or n minus 2 squared. So then there are n minus 2 to the power of 3 cubes without any outer face inside the big cube. So the other equation would then be n minus 2 to the power of 3, or n minus 2 cubed. And by using these two, we can make an equation. So 6n minus 2 cubed equals n minus 2 cubed. Okay, so we can divide everything n minus 2 squared on each side. We can do 6 equals n minus 2, and to get n by itself, we can add 2 on both sides. So now n equals 8. Now our answer would be D, which is 8. Alright, number 19. Christina has a set of cards numbered 1 to 12. She places 8 of them at the vertices of an octagon so that the sum of the numbers at the endpoints of each end is a multiple of 3. What are the numbers did Christina not place? Alright. So first what we can do is we can draw an octagon. Sorry, my octagons are really bad. Yeah, okay. So anyways, so let's put points on the vertices. So there's 8 of them, of course, because there's an octagon. Now, trying to find endpoints and which numbers. The endpoint is multiples of 3. So what we can do is we can label it 1, 2, 4, 5, and then we can make 7, 8, and then 10, 11. And then we basically just add them all, which is 21. And then when you add it, it's 3, 9, 15, and that was supposed to be 11. That was supposed to be 10. But then that basically equals 21, which is what we got earlier. So now, let's see. Okay, so now we just find numbers that do not have 3's in it, which you can cross out. So A, B, and C are crossed out. Then A, C, D, B, and E are left. Yeah. Okay. So now we can see that B does not work since there's only 2 multiples of 3. So the answer is E. Alright, 20. Harsh makes a net using a combination of squares and equilateral triangles shown in the figure. Side length of each square and each triangle is 1 centimeter. He folds the net into the solid shown. What is the distance between the vertices A and B? So the vertices join to form a square C, D, E, and F, which is 1 centimeter long. Oh my gosh, okay. So that's basically this representation. F, E, C, D there. Then as a triangle, we can basically split in half, and then M will be the midpoint of C and E. So now, what we can do is we can draw a triangle that basically represents half of that square. So CE, M is the midpoint, so it would be M, and now it would be 1 centimeter right there, and then there it is. And due to that Pythagorean theorem, we can make that the midpoint is square root 2 of the side length. So now, AMC is a rectangle with hypotenuse AC of length 1 centimeter and leg CM of length square root 2 over 2 centimeter. So now we can use the Pythagorean theorem. We can get A and absolute value of AN square root 2 meant to the power of 2 equals 1 minus square root 2 over 2 to the power of 2, and then that equal 1 minus 2 over 4, which is equal to 2 over 4, or 1/2 when we simplify it. So now AM would equal to 1 over square root 2, and then to get the square root 2 on the top, we can multiply it square root 2 on both the denominator and the numerator. So that will get us to square root 2 over 2. So now, to find the distance between A and B, what we are able to do is we can get square root 2 over 2 plus 1 plus another square root 2 over 2. And that is basically 1, 2, square root 2 over 2. And to simplify that further, we can cross out 2 on both the numerator and denominator, and that's 1 plus square root 2, which is our answer. And that we can find this answer on B. So that is our answer. Alright, on to question 21, where the problems are now worth 5 points each, and this applies for 21 to 30. So yeah, okay. The prime factorization of the number n factorial is 1 times 2 blah blah times n is in the form shown in the diagram. Just right there. The primes are written in increasing order. Ink has covered some of the primes and some of the exponents. What is the exponent of 17? So that's what we're trying to find. Alright. So the appearance of prime number 47 shows that 47 is less than or equal to n, and then also less than 53. The reason why I put 53 at the end, because that is the next prime in our list that they have given us. So since 13 to the power 4 is part of our prime factorization, so that means 4 multiples of 13 will be included. So what we can do is we can draw that. So n factorial, and then I'm gonna write 13 so we don't get confused. So then now that equals 13, 26, 39, and 52. And we can say that n is equal to 52 because 47 is, it fits in the category that we put in the beginning. Yeah. To put it in easier terms, so then now you can see that there are 3 multiples of 17 that would fit before it reaches 53. So the multiples are 17, 34, and 51. And since that fits in our category, this would make our exponent of 17 3. So it's C. Alright, number 22. Carl always tells the truth or always lies on alternate days. One day he made exactly 4 of the following 5 statements. Which could he have not made on that day? Okay, so first off, statement B can only be made by a person who lies on that day. So right now he's lying, we can assume, and the reason why is because it says tells the truth or always lies on alternate days, so he switches alternatively, so that does not work. So then he would have to tell the truth today and then lie tomorrow, so that doesn't work. Okay, and then tomorrow is Saturday and yesterday was Wednesday. Does not work because they do not correlate. And then A, I lied yesterday and I will lie tomorrow. Same thing as B, so the only thing that is left is C. So our answer is C. Alright, number 23. Sum of the digits of the number n is 3 times the sum of the digits of the number n plus 1. What is the smallest possible sum of the digits of n? So what we know, the sum of digits of a number is less than those of the next larger number only if the number has 9 in the last digit. So what we can put is that the last digit is 9. I put last D is 9. And then now the next number has to be 0, so then it could be plus 1. So that's how it works. So in that case, the sum of the digits of the number n plus 1 will decrease by 8, because how we get 8 is we do n plus 1 equals the last digit, which is 9, minus 1 on both sides, and then n equals 8. So decreases, so basically it decreases by that factor. Okay. So now it says 3 times. So that means we are able to get this equation after what we found. So x equals 3 x minus 8. And then solving that, we can do x equals 3x minus 24. And then to get x by itself, we can minus 3x on both sides. So now that becomes negative 2x equals negative 24. And then to get x by itself, we just do divided negative 2 on both sides. And x equals 12. So now the smallest possible sum is 12, which is B. Question 24. Jo has some black, gray, and white unit cubes. She uses 27 of them to build a 3x3x3 cube. She wants the surface to be exactly 1/3 black, 1/3 gray, and 1/3 white. The smallest possible number of black cubes she can use is A, and then the largest possible number of black cubes she can use is B. What is the value of B minus A? So smallest is A, largest is B, and we want to find the value of B minus A. So what we can do, we can find the surface area of the cube, which is 6 since 6 faces multiplied by 3 to the power of 2. So then 6 times 9, which is then 54. So the surface area of the cube is 54. Using that information, this means that the black, gray, and white area should be equal to 18. The reason why I get this is because 54 divided by 3, which is just 18. So in a cube, what we can see is that there are 8 corners. 8 corners, and then there's 12 edge cubes. And then there are 6 centers of faces, since there's, 6 faces on a cube. And then to find the small cube, what we can do is we can do the 18 for each, which is what we did. So 18 times 1/3, because the 1/3 black says it up there. Then cross it out, has the same 3, and then equals 6. For the large cube, what we do is 18 multiplied by 2/3. So it's over 1, same thing. And then 6 times 2 is 12. And since there's one extra cube that we cannot see, and it's in the same color, so we add 12 plus 1. So there are 13 black cubes. So now the largest is B, so B minus A. 13 minus 6 equals 7. Alright, number 25. Anne rolled a normal die 24 times. All numbers from 1 through 6 came up at least once. The number 1 came up more times than any other number. What is the largest possible sum Anne could have obtained by adding up all the numbers? Alright, so since Anne rolled the dice at each number at least once, we can say, and we can guarantee, that 6 of the rolls have a sum of 1 plus 2 plus 3 plus 4 plus 5 plus 6. So right now, that's 3 plus 7 plus 11. Okay, so then that's 21. So now we can consider the next 18 rolls, and we get this by doing 24 minus the 6 roll that she did. This is how we get 18 rolls left. So now we know that there should be more 1s than other numbers, because it says the number 1 came up more times than any other number in the problem. So what we can do is we can consider different variables. So first, if we have 9 1s, then we can have 8 6s and 1 5s, and that is basically equal to 9 plus 48 plus 5, which is then 62. So let's see. Now 8 1s, we can have 7 6s and 3 5s, and that would equal to 8 plus 42 plus 15, which equals to 65. So we're just going to cross those two out for now, just in case. And then we can also have 7 1s, which we can do 6 6s and 5 5s. So that's 7 plus 36 plus 25, which is equal to 28. Which is equal to 68. Okay, and then 6 ones. You can do 5 sixes and 5 threes and 2 fours, and that would equal to 6 plus 30 plus 25 plus 8. And then this equals to 69. This is the highest sum for 18 rolls. So if we were kept going, they would not work. There would be fewer ones. So now, the way you get these is basically you just find the most efficient way. So I'm just showing you the most efficient way instead of keep going. So now we just do 69 plus 21, which is 90 rolls in total. So our answer is D, which is 90. Olivia walked in the park. She walked half the total time at a speed of 2 kilometers per hour. She walked half of the total distance at a speed of 3 kilometers per hour. She walked the rest of the time at a speed of 4 kilometers per hour. For what fraction of the total time did she walk at a speed of 4 kilometers per hour? Okay, so we can write down the speed so it's easier for us on the side. So there's 2 kilometers per hour, and then there's 3 kilometers per hour, and then there's 4 kilometers per hour. There it is. And now the next category that we're going to put next to speed is time. So she said walk half the total time. So since it's total time, we're just going to put the variable t. So then for 3 kilometers per hour, she says she walked half the total distance. So for her time, it's t minus x, and then for kilometers per hour, it's just x because it's the rest of the time. So now for distance, I'm gonna put d on the top. So then distance, we just multiply, so 2t, and then 3t minus x, and then 4x. So then what we do, we can put it into an equation where it is 3t minus x equals 2t plus 4x. So now to solve for that, what we were able to do is we can do 3t minus 3x, which equals 2t plus 4x. And then what we were able to do is we can add 3x on both sides. And then we can also minus 2t on both sides, so it's easier. So then t equals 7x, and then to get x, what we were able to do is divide each side by 7. So then x equals t over 7, and then what we do is x equals 1 over 14. So then we do 1 over 14 multiplied by 2t. So then now that is technically 1/14 of her distance. So the answer is A. Alright, number 27. Ali wants to remove some of the integers from 1 through 25 and then separate the remaining numbers into 2 groups so that the products of the integers in each group are equal. What is the smallest number of integers Ali could remove? Okay, so the prime factorization of the products of the numbers of both groups have to be the same since products are equal. So then that means the prime numbers have to be in the list of 1 through 25. And the prime numbers that we need to get rid of is the ones that have only one multiple. So these basically include 13, 17, 19, 23, nothing over 25. So there. And now, what we know is that 7 has 3 multiples among the numbers from 1 through 25. So we can make a list of 7 multiples, which is 7, 14, and 21. Again, nothing over 25. So then at least one of them has to be removed, which only works with the deletion of 7. So we do not include 7. So that means what we do is we are able to split the remaining numbers into 2 groups that have an equal product. So what would it would look like is 3 times 5 times 8 times 14 times 15 times 18 times 20 times 22. Ooh, let me erase that. Okay, and then times 24 is also equal towards 2 times 4 times 6 times 9 times 10 times 11 times 12 times 16 times 21 times 25, and that basically just equals 2 to the power of 11 multiplied by 3 to the power of 5 times 7 times 11. So that means the smallest numbers that she can remove is 5. Alright, number 28. 20 points are equally spaced on the circumference of a circle. To draw all possible chords that connect pairs of these points. How many of these chords are longer than the radius of the circle but shorter than the diameter? So that's what we underlined. Okay, so let's pretend that there's 20 points on the circle and each point is connected with 19 other points. So it forms 19 chords. So one of these 19 chords is exactly equal to the diameter, leaving 18 chords that we have to consider. So what we can do is you can write that down. And then, for example, there could be a triangle there that would shown to be connecting. So let me draw a shape on the inside so it's easier. My shapes are really bad because this is online. So yeah, okay. And then for each chord to be larger than the radius, its central angle has to be larger than 60 degrees because of an equilateral triangle. And since 20 points form a regular 20 gon, the central angle of the chord connecting two adjacent points is 360 divided by 20, which is then 18 degrees. So therefore, the angle needs to be at least 4 times that of 3 times 18 equals 54 is less than 60. So it has to be 4 times of that. So now, what we're able to do, 3 pairs of chords from a point to its nearest points along the circumference are going to be shorter than the radius because there's different lengths. And this leaves it with 6 pairs of chords or 12 chords per point. So each chord is counted twice. So the total number of chords is, we can make an equation, 20 times 12 divided by 2, which is then 240 divided by 2, and then 120. So that's how we get C as our answer. Okay, number 29. There are n distinct lines on the plane labeled line 1, blah, 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 line n. The line L1 intersects exactly 5 other lines. The line L2 intersects exactly 9 other lines. And the line L3 intersects exactly 11 other lines. What is the minimum possible value of n? Okay, so L1, which intersects, I'm going to put I for intersects, 5 lines. So that means n has to be greater than or equal to 6. L2 intersects with 9 lines, so n has to be greater than or equal to 10. L3 intersects with 11 lines, so n has to be greater than or equal to 12. And then n has to be greater than or equal to the max of 6, 10, and 12. So what we can do is we can draw lines. I found the most efficient way, so I'm going to show you. So what we can do is we can do 7 parallel lines. These lines don't look parallel, but yeah, I tried. So there's 1, 2, 3, 4, 5, 6. Oh, there's 6 lines right now going parallel. Now I'll add one more, and there are 7 parallel lines going in this direction. So then what we're supposed to do is we can do 3 lines sideways like this. So 1, 2, 3. Then another thing that we were able to do is get around a line this way, and then one more line there. So then that's how our diagram looks like. L3 goes on the line that's like this, L1 goes on the line that's like this, and then L2 goes on the line that's like this way. So then the minimum possible value is 12 since it intersects 12 lines. Let's go number 30, last question. Okay, Suppose m and n are integers with 0 is less than m, less than n. Let p equals m and q equals n, m, and o equals 0, 0. For how many pairs of m and n will the area of triangle OPQ be equal to 2024? Okay, so what we can first do is find the area of the triangle, which is A, and then triangle QPOOPQ, same thing. Okay. So what we're doing is n squared minus mn minus 1/2 and minus m squared. Okay. So now after that, we basically simplify that to 1/2 n squared minus m squared. Oh, let me rewrite that. Okay. So then we can set that equal to 2024. So then this becomes n plus m, n minus m, and then we can multiply both sides by 2 to get rid of the 1/2, so then now it becomes 4048. So since m and n are both integers, n plus m and n minus m are either both even or both odd. So there are 6 ways that 4048 can be represented. So we'll do product factorization to make it represent as a product of 2 even numbers. So it could be 2 to the power of 4 times 11 times 23. So then there can be pairs, which are some examples. So 2 times 2024, and then 2 squared times 1112, and then 2/3 multiplied 2 to the power of 3 multiplied by 506, 2 times 11 times 2 to the power of 3 times 23. And then there's also 2 to the power of 2 times 11, and then multiplied by 2 squared times 23. So that is already 5 pairs, so one more. And then 2 times 23, and then it's 2 to the power of 3 times 11. So there are 6 possible pairs that we found. So that means our answer is B. Alright, thank you for watching. Bye!
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website. So bye!